Okay. Let me share my screen. Can you see my screen?
Yes, we can see your screen. Yes.
Yeah. Hello, everyone. I'm Wang Yang from the Volcano community, and it's a great honor to participate in this exchange. Today, I'm mainly share Volcano from the following four aspects. The first is project introduction of Volcano, followed by the application and the demo of Volcano in AI, HPC, and big data. And then the introduction of the core feature of Volcano, including the demonstration corresponding to the feature. And finally the introduction of Volcano typical case of landing. The first part, Volcano project introduction, with a continuous environment of business scenarios. Batch computing has greatly expanded from traditional HPC to various scenarios such as big data and AI. However, each field develops independently, presenting problems such as ecological fragmentation in competitive technologies tech and low resource utilization scenarios affect the future development of base computing. Cloud native technology is valued by various communities and many features for its rich ecology and flexible scalability, and build a unified base computing system based on cloud native technology to improve resource utilization. Cognitive based computing mainly face the following challenges: insufficient support for job management and domain framework, and the lack of in-depth support for scheduling performance, resource contribution, heterogeneous computing. To solve these problems, the Volcano project were born. Volcano is an industry first cloud-native-based computing platform. It was officially open sourced in January 2019. In April 2020, Huawei donated it to CNCF, become CNCF's first base computing project. As of July this year, Volcano has released 23 versions. Every three release a version every 4 months. At present, there are more than 500 community contributes. From the picture on the left, we can see that the Volcano project has a lot of cooperation with the upstream domain computing framework, and currently support almost all many mainstream domain computing framework in the industry. Big data fields such as Spark, Flink, AI fields such as TensorFlow, MXNet, Underspot, PyTorch, and OpenMPI. In addition, Parallel pipeline support is also provided through integration with Argo. As you can see from the architecture diagram below on the left, Volcano is more than just a scheduler. It has a job and a job controller to support it has the job lifecycle management. It has queues to provide the resource planning and self-multi tenancy. For underlying hardware, we also working on supporting heterogeneous device to better manage the x86 ARM NPU and working with Kubernetes to improve performance for batching workloads. Volcano defines batch job resources and support mainstream job type in the industry, such as MPI, PyTorch, TensorFlow, through a unified type interface. Volcano job contains the following key information. Schedule name specifies the name of scheduler used. Main available means that only when the main available number of port resources satisfy the job with will they be scheduled together. Plugins extend the job API and define customized requirement policies, configuration, configure job lifecycle management policy. Task name specifies the type of task in the job. Task replics specifies the number of copies of the task. Most batch computing workload including multi-different task type, such as TensorFlow, PS and worker, MPI master and worker. At the same time, the images used by different task type require different resources, such as TensorFlow's PS mainly use the CPU resource, while workload tend to use GPU resource for acceleration. Tasks support a variety of replica information definitions. You can specify the type of task in the job through task name and specify the number of copies of the task replics. Volcano provides the job plugin and the scheduler plugin. The job plugin, as shown in the left picture, are mainly used to help Volcano support upstream computing framework, including MPI, TensorFlow, PyTorch, and the scope is current job. The scheduler plugin is shown in the figure on the right. It's mainly used to kind of the scheduling policy in the scheduler. It's configured in the kind of schedule config map and takes the effect for all jobs scheduled by Volcano. Application of Volcano in HPC, AI, and big data. We can take a look at how commonly used upper-level computing framework jobs are scheduled and run through Volcano. The first is PyTorch job. Example of PyTorch job is as follows. First, you can set the job type according to business requirement. Configure the role and the port information of PyTorch job through a general plugin provided by Volcano. Configure the processing strategy when the job is abnormal, and restart the entry job when the port is in job is evicted. Configure job terminating policy. The entry policy job is consisted complete when the PyTorch master is complete. In the Kubernetes cluster with kind of installed, execute the above demo, and you can see that the PyTorch job is successful scheduled and running. The figure below shows the running result, and we can demonstrate in the test environment. This is Kubernetes cluster installed through Kant with a total of four work nodes. Among them, Kubernetes is version 1.25, and Volcano has been installed with its version 1.7. Now we can first briefly look at the YAML file of the PyTorch job. Which is consistent with the description in PowerPoint. Now we run the PyTorch job and watch the job. Oh, sorry. I'm sorry, it's work on just now. Not sure if there is something wrong with my environment. We continue next. Yeah. Below we can share the running of the TensorFlow job. First of all, the user can set the label according to the actual business need, identify the current job type, and use it for classification and retro. Of course, it's not necessary to set. Use the job plugin env and SVC provided provided by Volcano to simply the general configuration information of the TensorFlow jobs, such as enable SSH password-free authentication, automate automatic create a headless service to solve communication problem between PS and the worker, and configure job restart policy. Set the PS running information in the TensorFlow job in the task, and set the job running pod information. As shown in the figure, we configure the job termination policy, work running information, and the pod configuration information in the work. After running the above demo, report of the TensorFlow job is scheduled and running normally, and the job output information is as shown in the figure below. We can actually run it in the test environment. This is the YAML file of TensorFlow job, which is consistent with the job configuration info displayed in the PowerPoint. Now we will send the TensorFlow job through kubectl. You can see that all pods are successfully scheduled and running as expected. Now we clean up the source we just created. MPI job, similar to the previous PyTorch and TensorFlow, the MPI job can set the job type according to the user's business need. Configure the role and the pod information of MPI job through the general plugin provided by Volcano, and configure the job restart strategy. Configure the job in termination policy in the task. When MPI run completed, the enter MPI job is considered complete. Setter must contain the startup comment, host IP mapping field are stored in etc Volcano. First start the SSH service, then run npm run to start the npm job. The container exposed port 22. Here is configuration for information of worker role. Set the worker containers start comment, only start the SID service, and the containers expose port 22. After running the above demo, the MPI job can be scheduled and run normally. During during the running of the MPI job, the master pod may be restarted during the running process due to network construction delay. This is normal phenomenon. After MPI job ends, the job will return the master pod and delete the work pod. We can also look at the log output of the master pod. The information is is shown in the following picture. Below we can run MPI job in a test environment. This is YAML file of MPI jobs. We sent the MPI job through kube control to show the running state of the job. Just wait a minute. There is a delay in network creation. Yeah, we can say after the pod is running, it becomes completed. Now we check the log information of master pod. Yeah, um, it's in line with the implementation. Now we clean up the resource we just created. For big data, Volcano support job scheduling operation such as Spark and Flink. Let's take Spark as an example to see how Volcano performs scheduling. In 2020, Volcano will cooperate with Spark Operator, Flink Operator open source project, becoming the first cloud native project to provide it with best scheduling capabilities. In 2022, initiated by Volcano developers such as Apple, Cloudera, Netflix, and Databricks will work together to complete it. The Spark community will support customized Kubernetes scheduling from the framework level and promote Volcano as the first best scheduler of Spark on Kubernetes. The process of cloud native integration in the data field. Volcano manages Spark jobs through pod groups, including Java pod and Qt pod. In the case of tight cluster sources, it can avoid deadlock and business of resources of multi-Spark jobs. Before submitting a Spark job through Spark Submit, we first set up pod group related configurations. Main resource indicates the mean amount of the resource requirement required to run Spark job, including Java pod and Qt pod. It's useful for in source available resource meeting the member requirement of Spark job and avoiding the situation where the drivers are scheduled, and then they are unable to schedule a sufficient queue to progress. Submit a Spark job through the submit method, and the place marked in the red is the configurations different between using Volcano scheduler and the Kubernetes default scheduler. First, specify the scheduler as Volcano, and specify the port group configuration field we just set up, and finally add the custom feature step. After running Spark job demo, the Spark driver port is first pulled up, and then the Qt port is scheduled and run. We can demonstrate the actual running of Spark job in the environment. Port group templated is the port group configuration for configuration information of Spark job. We submit the Spark job about running. The Spark job running successfully. Now we clean up the resource we just created. In the third part, let's share the core feature of Volcano. It mainly includes six core features, namely job policy, gun scheduling, fair share, priority, preempt, and queue. The first is the lifecycle management of the job. Volcano job contains several different status, including pending, abort, running, completed, and terminated. The above table show the transition relationship of the different state of the job. After the job is created in the system, the pod in the job will have different event information, such as pod failed, pod evicted, unknown out of sync, command issued, task completed. We can perform different processing according to the different time status report. And the lifecycle strategy of the job is it's mainly used to process such as event information for user configuration. In fact, we have already configured such as strategy when running PyTorch and MPI jobs before. That is when encountering pod evicted events, restart of progressing is performed. And when the MPI master pod is task completed, the job status is updated to completed. Below we can demonstrate in detail the content of the job lifecycle progressing. Strategy we config is when any pod in the job is evicted, the entry job field. Any pod in the job is expelled. Job changes to the aborted the state, and all pod in the job are cleaned up. Let's run the current demo through the test environment. Policy job abort is currently use case information. We can simply look at it. After running the job, delete one of the port. Now we can see that all ports have become terminating state. Texture state information of job with kind of job it's aborted state. Yeah, now we can clean up the source disaster created. In the second example, within the same job, diff, mm, different different type of tasks require different policies. Volcano allow you to configure policy for specific type of tasks. For example, the processing policy for the pod evicted event in the job is restart job. But after copy in the worker is evicted, the user wanted to restart only the current port without affecting the operation of the enter job. Then the policy can be added to the work role information of the task. In the current configuration, if port with the role of PS is expelled, the processing policy of the job will be followed to restart the entry job. If a port with the role of worker is expelled, the policy set in the worker will be used to restart only the current port, not other port in the job maker are impact. This is a packed result. We can actually run it on the environment to see. Uh, yeah. First run the policy job task job to expel a pod in the workflow. We can see that currently only the evicted pod are rescheduled without affecting other pod in the job. Wait a moment for pod to recreate successfully. Let's verify again. Expelling the pod over the PS row. Now we can see all pods in the entry job will be affected and rescheduled. Wait for pod to be deleted and recreated. Now we clean up the resource we just created. Let's share the core feature gun scheduling in Volcano. The gun scheduling strategy is one of the core scheduling algorithm of the Volcano scheduler. It meets the all or nothing scheduling requirement in the scheduling process and avoids the waste of cluster resource caused by arbitrary scheduling overport. The specific algorithm is to observe whether the scheduled number of pod and the submit the mean running numbers. When the mean running number of the job is met, the scheduling action is executed for all pod under the job. Otherwise, it's not executed. The keyword in Volcano job is mean available. The gun scheduling algorithm based on the container group concept is very suitable for scenarios that require multi-process cooperation. AI scenarios often contain complex processes such as data uh, ingestion, data analysis, data splitting, channel serving, logging, which require a group of containers to work together, which is very suitable for the gun scheduling strategy based on the container groups. The multi-structure parallel computing communication scenarios and the MPI computing framework is also very suitable for using the gun scheduling strategy because the master-slave process need to work together. The containers and the container groups are highly uh, correlated and there may be resource contention. The overall scheduling and the allocation can affect show the deadlock. We can check the free resource information of the test cluster first using CPU as an example. There are currently 4 worker nodes in the test cluster, and the total resource of each worker node are 4 CPUs. Uh, Excluding the inherent inherent resource consumption of each node in the cluster. The resource of each node are about 3.9 CPUs. For the comparisons of calculation, I'll follow up the main member unit of pod scheduling resource application is 1 CPU. The available resource of each worker node are 3 CPUs, and the overall idle resource of the cluster are 12 CPUs. Gun job is demo simple. It's simple. We can take a look at corresponding main available information setting and requirement information. Now run the gun job demo. We can say the phenomenon mom, moment is consistent with the expectation. Now we clean up the source we just created. Volcano's fair share. Fair share is typical capability in electric job and streaming jobs. The default scheduler in Kubernetes actually imply a priority. That is, the smaller the task, the, e- the easier it's to be scheduled successful. In this case, pods that require a lot of resources are likely to face long waits. In addition, in the scenarios where multiple business terms share resource pool, terms that submit a large number of jobs can often get implicit priority because scheduler spend a lot of time helping to schedule their business. Kind of provide job level resource fair scheduling through DI. In the example, in the figure, uh, we can say that even though more jobs are submitted in job two, job one and job two are run with the same amount of resource. This demo contains three jobs. The number of copies corresponding of job A, job B, job C are 12, 6, and 48. Uh, 48 respectively. First, submit job A to uh, calculate the remaining resource of the cluster, and then submit job B and job C. At this time, job B and job C is waiting state. Delete job A, release 12 CPU resource in the cluster, and the jobs of job B and job C are scheduled. Let's observe the scheduling result. The reason why job A is submitted first here is to include the influence of the order of submission of job B and job C on the scheduling result. According to the fair scheduling strategy, 12 CPU idle resources in the cluster job B can be allocated 6 CPU, and job C can be allocated 6 CPU. The result is that all 6 copies of job B are running, and among the 48 copies of job C, 6 copies running, 42 copies pending. We can run this demo on test cluster. Delete job A and wait for job B and job C to be scheduled. We can say that the current result is consistent with the expected. Now we clean up the source we just created. Job priority scheduling. The priority represents the importance of the job. High priority jobs are given priority to obtain cluster resource. When resources are inf- insufficient, insufficient, uh, high priority jobs are allowed to preempt low priority jobs to obtain resource. In the production environment, we usually we usually have some urgent or important application load, and the SLA of this load need to be guaranteed guaranteed first. In this scenarios, priority scheduling will be very important. Define three priorities, namely high priority, middle priority, and low priority. Create three jobs corresponding to the priorities created above. Where job A is high priority, job B is the middle priority, and the job C is low priority. And the requested results are all 12 CPUs. First, create job A to occupy the remaining resource over the cluster, and then submit job B and job C. At this time, the cluster has no idle resource, and job B and job C are in queue. Delete job A, releasing the 12 CPU resource of the cluster, sort class sort by priority, and the job B is scheduled the first. The reason of creating job A first is to include the impact of job submission order on scheduling. I show in the figure, figure, and all idle resource of the cluster will be allocated to job B, uh, namely the priority medium test job. We can run it on test cluster according the above step. Now we delete the priority high job. After the cluster resources are released, they will be allocated to priority medium job. Yeah. Okay, let's move on to next feature. Now we clean up the resource. Volcano是 job preemption capability. Create two jobs corresponding to low priority and high priority. First, submit the low priority job, job A. The requested resource is 12 CPUs. Uh, after all report is in the job are running, submit the high priority job B. Uh, the requested resource is 8 CPUs. The high priority job preempts the low priority job's resource, and all 8 copies of the job B are running. The 8 copies of the low priority job are evicted, and the remaining 4 copies are running. We can run the above demo on the test cluster.
Van, how are you saying that this will be preempt in the YAML file? Where are we saying that this job will be preempted?
Uh, Sorry, my English is poor. So we can say preemption low. Uh, this is priority defined,
Okay.
and this is high priority defined. Yeah. Just wait a moment. We can say that all high priority jobs reports are running. So successful preemption of high quality jobs. Now we clean up the resource. Yeah, let's share the key feature of Volcano queue. Queue is a classic concept in the traditional batch system and exists in systems such as Yarn and Slurm. In Volcano queue is defined as cluster level resource object, which can be easily coupled from namespace and shared by multiple namespace to active resource isolation and sharing. The queue in Volcano can declare resource quotas, such provide the direct and soft isolation of resource pool. In actual business use, usually um, a queue is mapped to a term or department in business, and the cluster resources are uh, softly divided by the weight of the queue. As shown in the figure, if there are 2 queues in the cluster, namely Q1 and Q2, and the corresponding weight value are 2 and 1 respectively, and there are 6 CPUs idle resources in the cluster. Then the resources obtained by Q1, so weight division are 4 CPUs, and Q2 should be the obtained resource is 2 CPUs. When the resources of Q2 are idle and the load of Q1 is high, you can temporarily zero the idle resource of Q2 to run the jobs. When a new job is submitted in Q2, the resources of Q2 will be recycled, and the queue is realized in this way. The ability to share dynamic resource between cluster improve the overall resource utilization of the cluster. Let's look at an example. Create QA with the weight of 1, create QB with the weight of 3, and the cluster 12 idle resource. QA logically allocated the 3 CPU resources, and the QB logically allocate the 9 resources. Some made a job application 10 CPU resources in QA. Through the dynamic resource function capability between queue, the pod scheduling of job A in QA is successful. We can run the current demo in environment. Now we can look at the state of QA. You can say that the weight is 1. The duration resource is 3 CPUs, and the currently used resource is 10 CPUs, which is in line with the expectation. Now we clean up the resource. When dividing the queue resource by weight, it's also about setting harder constraint on the upper limit of queue resource. I show in the figure by setting the capability of the QA to 4 CPUs. It means that the upper limit of the resource used by jobs in QA is 4 CPUs. Create 2 jobs, name job A and job B. The resource requested by job A is 3 CPUs, and the resource requested by job B is 2 CPUs. The total is 5 CPU, which extends the resource limit of the queue. After job A is submitted and scheduled, if job B is submitted, the requested resource exceed the upper limit of QA and will not be scheduled. We can run this demo on environment. We can say that job B has been in the pending state. Yeah, now we clean up the resource. After selling the core feature of the Volcano, let's share two practical case of Volcano in actually users. 小红书 is top level content sharing community with more than 100 million monthly active users. One of the core service is the recommendation function on the homepage. The recommendation model has nearly 100 billion parameters. The training cluster has thousands of computer nodes. A training job contains hundreds of PIs and workers. So Xiaohongshu has strong demanded for optional topology scheduling, high performance and high throughput. After introducing algorithms such as Volcano topology aware scheduling, packing, and SLA, the overall training performance is improved by 20%, and the O&M complexity is greatly reduced. Second, ING provides service in more than 40 countries, and its core business are banking, insurance, and asset management. During application of cloud native infrastructure and the process of creating a new generation of big data analyze self-service platform, the critical challenge ING face are how to unify interactive service, resident service, and offline big data into one platform. How to provide fair resource allocation to ensure business SLA. How to maximize resource utilization through the resource reuse mechanism, and how to increase the response speed, use preemption capability for key business. With the help of Volcano's rich scheduling strategy and optimization of Spark, ING has smoothly migrated its business from Yarn to Kubernetes, and the DAP platform based on cloud native infrastructure has been applied to 17 countries regions with 1,100 users. The number of users grew at an annual rate of 8.1%. The number of DP platform operating projects also grew to 450. Yeah, that's all I have to say. Thank you very much for your participation in listening to my rather long presentation. If you are more interested in what content, we can conduct in-depth exchange. Yeah, thanks.
Thank you, Wang Yang. It was really interesting to listen, and obviously having a demo of all the features was really helpful. Okay, is there any questions? Please, I think, unmute yourself and you can ask.
Yeah, hello. This is Dirk speaking. I have a question. First of all, thanks for this nice presentation. That helped a lot to get a better understanding of Volcano. What has not become, say, completely clear to me is, I mean, is in this Kubernetes cluster, because you were referring to the Volcano scheduler, but do you still have, say, another scheduler in place, or is then everything governed by this Volcano scheduler?
Wang, I think let me repeat it. Maybe I think is there in the Kubernetes, is there a separate scheduler, or is the Volcano scheduler integrated with Kubernetes, right?
Yeah, because I mean, when in your configuration files, you always say define the scheduler. We somehow suggest that there could be another scheduler in place.
Just wait a moment.
Maybe stop sharing your screen. Maybe that might. Okay, go ahead. Wang Yang, I think the question is mainly, I think, do we need to specify the scheduler name in the YAML file, and why are we doing it? Is there another scheduler? That's what Doug's question is.
Hello, are you seeing the scheduler name in the Java YAML file?
Yes, we are seeing the scheduler name in the YAML file, right? Like Volcano.
Yes. Yes, the scheduler name it is a mandatory field that user need to specify the scheduler name. The Kubernetes supports user to specify multiple different schedulers. So it's a convenient way for user to configure this scheduler name.
What are the other schedulers available? Like, let's say Volcano is one scheduler. So, like, what are the other schedulers? Is there an inbuilt scheduler, or what are the other options we have here?
As far as I know, there are some scheduler name like Unicore, another batch scheduler, or the default scheduler, and also the coordinator scheduler. Yeah, there are about 4 or 5 schedulers currently from different company or different community. But for batch area, the Volcano scheduler is the most popular right now.
But if you look at one specific instance, would you expect that there are multiple schedulers which are managing the resources available within this one particular instance?
You mean within one cluster, do you want to use multiple schedulers?
Well, I don't want to. I mean, that's why I got a bit surprised about say having this as a configurable parameter, right? I mean, you could also turn around the question. I mean, if I have one instance with one scheduler and then somebody is requesting another scheduler, what would happen?
Yeah, the question is, can we have multiple schedulers within a single instance?
Hello?
Hello, yeah, Wang,
Yeah.
tell me, can we have multiple schedulers within a single instance? Can we have Volcano as well as, let's say, another scheduler name, let's say X? Can they live in the same cluster?
Currently, one scheduler is one instance for one scheduler. So in most scenario, in one cluster, we configure the Volcano scheduler for batch and the default scheduler for microservice. This is the most user use this way. And for some batch cluster, the Volcano can be deployed for the all workload.
Okay. So if I use multiple batch schedulers, it will work, but it may cause some issues. Is my understanding right?
Yeah. In most cases, multiple scheduler works plays well in one cluster. But we also found some corner case, like if if the workload is very heavy in one cluster, so the two scheduler allocate resources from the one node at the same time. In extremely heavy workload. There are some inconsistency issues.
Yeah, I can easily imagine.
So we usually recommend the user to specify use one scheduler in one cluster. It is the best. It's the best way.
Okay. So we use one for batch scheduler, one for microservices. At least that should work. Okay, thank you. Sabri, you want to ask something?
Yeah. Yes. So thank you for the presentation. It was great. So I have just maybe some concerns regarding integration in the DeSize framework. So one thing is how easy it is to adapt or extend volcanoes. So if you would have some, let's say, request to make some small modification scheduling policy that just for experimentation purpose or to see if there are some, let's say, advantages. So how this would work? So would we count on that we ask, let's say, Huawei team to help us to make this modification so that we could see if there is some advantage in scheduling, or would that be possible, or how extensible it is? So it's simply a practical question for experiments in this size project, how this would work. So would we count on direct cooperation with Huawei to make these changes of Volcano so we can see if we get something, some advantages, simply for research purposes? And if you see that it's good, then of course it would be used in the next, let's say, production version of Volcano. But is this something that would be possible in cooperation with Huawei?
Let me answer the DeSize part at least. Volcano is an open source project, and I understand. I think anyone can go and change it and update and see how it works. So that is on point. On the second point, I think we'll have Huawei resources supporting at least Volcano. That is the plan, but we need to exactly find how much support we can get. But Wong, you want to maybe tell how easy it is to extend Volcano, to add things actually, or experiment with it?
Do you mean how to apply Volcano in experimental environment?
No, I think how to change Volcano. Let's say I want to add a new scheduling. I want to add a new policy, or I want to have a new algorithm placed there. How easy is it to extend this solution for new things?
Okay. So Volcano framework supports user to customize the policy very easily. You can define your customized the resource allocation logic, and the framework provides some pluggable functions to use. So maybe I can send you some material to show you how to write customized policies with the function.
Yeah, that would be great. So, because this is a research project, and our intention is to try something to see if it has some advantages in practice. And if Volcano has some plugins, mechanism, or some configuration files where we could specify this, that would be great, and it would be easy to try different things. But of course, we would look also for direct cooperation with your teams. So we are project partners, and your experience with Volcano would save, of course, a lot of time that you would have to spend to get let's say, familiar with the whole thing, how it is implemented.
I think for the DeSize project, at least we have Vittorio, who is going to lead the efforts from Huawei, from these tools. But Wang Libo and Wang Yang, they are based in China. They are part of our team in China. So they will support if required, actually. But Vittorio will be the main point of contact. And obviously, I think we can see what is needed, what level of support is needed based on this training, and what else we can do. We can discuss that internally. It's not a problem.
Okay, I had just one more question. Because we have reserved 2 hours, I think we still have some time. So
Yes, go on.
okay, my last question. So it's did you measure, let's say, the overhead of Volcano? I mean, how much it costs, let's say, to use Volcano in some context? I'm just talking hypothetically. If a program execution, let's say, it's 5 minutes, then from this 5 minutes, how much is spent for, let's say, scheduling or overhead or management of this? So have you tried to estimate for some concrete examples? Is this milliseconds, microseconds, seconds, minutes, or percentages of the total, let's say, execution of the program? So let's say there is a total execution of around 10 minutes, but within this 10 minutes is included everything what Volcano has to do. And then in percentage or in seconds, milliseconds, some time unit, do we have an idea just a bit about the overhead that Volcano introduces? Of course, that's not zero, but the lower it is, it's better. But we need to have some estimation, let's say, for typical programs that you have tried. What was the time that Volcano used compared to the total, let's say, execution time?
Sorry, I didn't follow you.
Okay, let me repeat it. Actually, what is the overhead of Volcano in running jobs? Actually, how much time does Volcano take to start up a job, or what is the extra time which we need to schedule it through Volcano? Have we measured it? That's the question. Let's say I run an let's say I have an MPI job. What is the, let's say it runs on 10 minutes. If I run the MPI job using Volcano, what is the overhead, extra resources or time used to, let's say, run this MPI job? That's a very interesting, that's what I was also thinking.
So from the for the scheduler overhead currently is the overhead depends on how the scale of the cluster and the scale of the containers in one cluster. But for us, the most challenge is not about the overhead. Currently, the challenge is about the throughput. As you know, from the traditional software such as Slurm to Kubernetes, the throughput is a big issue. In our cluster, we use the kubescheduler to test the performance, the throughput. For the scheduler need to, the throughput is about 100 per second. so it is very low. So we improved the performance, and currently the throughput can be about 1,500 pods per second. But this is not compared with the Slurm. It is not so good. So the throughput is the most challenge we are working on to try to improve. So for the overhead, currently it's not a big issue.
Okay.
Okay, thank you. So,
Sachin, you want to go?
Can you hear me?
Yes, we can hear you.
So I would like to continue Sabri's question. The main thing was, if we have some different algorithm which we want to incorporate in Volcano. So I would like to know how the same thing, like how easy or difficult it is, and what should be the procedure. For example, we can start with a agreed small use case, and then work on it. So what recipes would you recommend to do that?
I think Wang, as you see, I think there is a lot of interest in trying out new algorithms for scheduling. I think as Wang already mentioned, you will send us some materials on how to do it, but I understand it will be through policies. Creating new policies means you will have new algorithms. Is my understanding right, Wang?
Sorry, pardon?
I mean, Sachin is asking how to introduce new algorithm for scheduling in Volcano. I want to add a new algorithm for scheduling. How do I do it actually?
How to introduce new
scheduling algorithm. Yeah.
Are you saying introduce new policy, or?
It's like they want to introduce a new scheduling algorithm, let's say.
New algorithm, right?
New algorithm for scheduling, yes.
Yeah. So we have some SDK introduction to show how to currently the algorithm registration support is pluggable. We have some pluggable functions. You can insert your algorithm into the designed functions, and the framework can load the plugins and make the algorithm workable.
Okay, and would there be some support available in case we land in some trouble from the Volcano side?
So they're asking if you'll be able to support in case they have issues or doubts. I think let's say I think we'll be able to sort it out separately, but I think we'll have some help actually. But we have to understand to find exactly how much this would need. This is just support you're looking at, Sachin, or?
Yeah, because if we decide that we will go, like would like to incorporate this new algorithm or new path, and then because we don't know the inner like in and out of Volcano scheduler, so because we are not designed it. So in case we land up in some trouble and or some so would the Volcano team help us, because that is also, I think, an important issue which we might foresee in the future.
So I think the question is, Wang, is there any help available in case they find any issues in working with Volcano?
Yeah. You can file issues at the Volcano community or the Slack, we can see the issues and what you want to integrate or what you want to add, what want you to do, and we can work with you together to move on.
That would be really great. Thanks for this information.
Yeah.
Yeah, I mean, my expectation is that already, I mean, just to scope it a bit, I think it could already be extremely helpful to, say, provide some guidance on just, say, the entry points for adding a new scheduler. Then, of course, it will be up to the project, I mean, to work on a new scheduler, but just, say, leveraging your experience in integrating new schedulers, I think would be extremely helpful. I mean, like, say, achieving a kind of an, say, hello world milestone.
Okay. So maybe we can look at this as maybe a short, maybe some tutorial, online tutorial on how to do integrate your own scheduler or algorithm or change the policies on the SDK for Volcano. Maybe we can target that in a later date, I think. So Wang, is it possible to have an in-depth maybe some demo on how to use SDK, how to integrate and change Volcano scheduling? Is this something we can maybe look at it maybe in the future?
Sure. It's my pleasure to prepare the tutorial to how to customize, how to add customer algorithm.
Yeah, that's great. Yeah, I think yeah, I think we can come back with some tutorial on how to use SDK, how to change the policies, how to change, introduce new algorithms or new policies, or customize it. Maybe we can have a tutorial at a later date. Yeah. So, okay. Is there any other questions? Otherwise, we can close the meeting or training webinar. Okay, I see no questions. I want to thank Wang Libo and Wang Yong for obviously presenting and also preparing for this training workshop. I want to repeat that I really liked all the demos of each of the scenarios, which is really nice. One thing you could do is share all these YAML files with me. I will post it on the GitHub, and the recording will also be available on YouTube, which I will circulate later. And thanks again, everyone, for joining the call.